The overall goal of this method for simulating helmet impacts is to quantify helmet fit and retention and evaluate the risk of injury of different helmet fit scenarios.
This method can help answer key questions in helmet research, such as the effect of helmet fit on head and neck injury likelihood. The main advantage of this technique is that new insight into the effect of helmet fit on injury likelihood may be quantified using a simple methodology. Head exposure, as well as head and neck injury, may be studied with this method.
Simulate impact to the helmeted head by linearly guiding the head form to hit an impact surface. Assemble a drop tower to consist of an adjustable drop gimbal, an anthropometric test device, and a variable impact surface. Within the head form, arrange 9 uniaxial accelerometers in a 3-2-2-2 configuration to measure linear and angular accelerations at the head form's center of gravity. Next, set up a customized velocity gate on the impact tower to measure the impact velocity just before impact. To collect the head acceleration data, set up the data acquisition system. Use an anti-aliasing low-pass filter with a corner frequency of 4 kHz to filter the data prior to sampling. Then set the sampling rate of each filtered signals to 100 kHz.